All right, everyone, welcome to your first exam review. You guys should all have received a copy of this exam before today, so I hope you had a chance to look at it and come up with maybe some questions about things that aren't entirely clear. We have plenty of time to entertain any question you guys have, either directly related to the exam or if you have any other questions you might want to ask. This practice exam is only 25 questions, and we technically have 2 hours, right? So ask away if you have questions at any point. If you don't have questions, I'm just going to go through the test sequentially and go over the answers. Okay? So let's go ahead and get started. First question here is a drinking scenario. Consider a public policy aimed at drinking among young adults. Studies indicate the price elasticity for beer among young adults is about 0.5. If a six-pack of beer costs $10 and the government wants to reduce beer drinking by 10%, it should increase the price by 1%. Or by what percent? Okay, so to answer this question, let's focus in on the price elasticity of demand, which they say is 0.5. Now, how would we interpret that number right there? Want to take a stab at it? Elasticity of 0.5. Yeah.
That's the result of the change of Q over change of P.
Yeah, very good. So just as the way that's calculated is the percent change in Q divided by the percent change in P, and then that's in absolute value. Okay, so then if that's our definition of our price elasticity of demand, how are we going to interpret that number of 0.5? Well, the way we're going to interpret that is a 1% change in price results in a 0.5% change in our quantity demanded. Okay? So our percent change, we could think of this as 0.5 over 1, right? Our percent change in Q divided by our percent change in price. So a 1% change in price results in a 0.5% change in Q. Okay, so now what the question asks here is that we want drinking to fall by 10%, not 0.5%. So if a 1% change in price results in a 10% drop in if a 1% change in price results in a 0.5% drop in our quantity, how are we going to get a 10% drop in our quantity? How much do we have to change price? Okay, so if the change in P is 1, then the change in quantity is 0.5. So what are we going to have to do to get this equal to 10? How big does that change in P have to be? Yeah. Yeah, it's going to be 20. Right, 1% results in a 0.5% decrease. So we just scale that up. How are we going to get 10? We're going to have to increase price by 20. Okay, so the answer then is going to be B. Okay. Oh no, there's no eraser. Does anyone have like a tissue or something by chance? Sorry, I should have figured that out beforehand. Thank you, let's grab one here. Thank you. Okay. Okay, question 2. Same drinking scenario. And here we have given the current price of a six-pack is $10. What should be the new price given the government's goal of decreasing by 10%? This is to use the midpoint method. Okay, so this is a question that you can make complicated by actually solving out using the midpoint method, what the change in price is. But this is also one that you could probably just eyeball the answer. Right? We know from question 1 that the price needs to increase by how much? By 20%, right? So which of these is approximately a 20% increase from $10? Yeah, so this is going to be the answer. Okay, so So a lot of these questions you're not going to need to explicitly calculate the whole thing if you can think about it logically like that. But just to be complete, to be thorough, let's actually calculate our change in price. Okay, so we're going to be using the midpoint method here. Okay, so we know that the change in quantity is going to be 10%. Okay, so our numerator is going to be 0.10. All right, so in our denominator, we're going to be using our midpoint method. So remember, you're going to take the change in price. So I'm going to put P here just to stand in for our new price. So our change in price divided by the average of the new price and the old price. So again, we don't know what the new price is, so we're just going to put a P as a stand-in, P plus 10, and then divided by 2. And we know that this should equal 0.5. Right, we know the elasticity is 0.5. What price do we need to do in order to get that? Okay, so here we've divided by a fraction. So to solve when you're dividing by a fraction, you can just multiply by its reciprocal. Okay, so this is going to equal 0.10 divided by P minus 10, and then times this here. So times 2 over P plus 10. Okay, so this was divided by a fraction, so I just multiplied it by its reciprocal. And this again equals 0.5. Okay, so now I'm going to do the same thing again. I'm going to multiply. This 0.10 is divided by a fraction, so I'm just going to multiply by its reciprocal again. And it's going to equal 0.1p plus 1 divided by 2p minus 20. And that still equals 0.5. Okay, so now I'm going to multiply both sides by 2p minus 20. So I get 0.1p plus 1 equals p minus 10. Everyone with me so far? Yeah.
0.5.
So it's the same scenario. So we're assuming it's 0.5. Okay. So we're going to add 10 over to this side. We get 11 equals, subtract 0.1 here, 0.9 p. Divide both sides by 0.9. And we get p equals 12.22. Okay, so if you just remember how you calculate the midpoint method, any random variable that you don't know, right? You just leave in some variable for it and solve. Okay, so this is a bit messy with the algebra, but the basic idea behind what we did is it's not too complicated. Yeah.
How come the denominator is p minus 0? Where'd you get the 0?
Oh, sorry, this is a 10.
Oh, okay.
Yeah. Any other questions? Okay. All right, question 3. Assume marijuana is legalized. If the cross-price elasticity between marijuana and beer is 0.2, well, then what will the effect be of an increase in price of beer have on the use of marijuana? Okay, so the cross-price elasticity is 0.2. 2. So what do we know about those two products? Yeah.
Be substitutes.
They should be substitutes. Yeah. So as the price of one goes up, the demand of the other goes up. Right? That's what we mean. We have a positive cross-price elasticity. Okay. If they're substitutes, right? What would it mean if they were negative? If it was negative 0.2, what would that mean? Yeah, they're complements. As the price of one goes up, the demand for the other one goes down. Okay, so then if that is true, then which of these answers is going to be correct? Well, we know it's not going to be A, right? Because they're not complements. We said they're substitutes. B, it will cause marijuana consumption to fall because they're substitutes. Does that make sense? I see shaking heads. Why does it not make sense? Price of beer is going up, right? So what should that do to, yeah?
That should also make marijuana to rise.
It should make, yeah, exactly right, right? Because they're substitutes. So the price of beer goes up, people will switch their consumption habits away from beer and to marijuana. Okay, so the answer is going to be D. Okay, question 4. You're a market analyst. You noticed the number of hardcover books sold fell between 2016 and 2017, but the price of hardcover books remained the same. What shifts in supply and demand, or both, could explain this observation? Okay, so let's just go through each one and see if they make sense. First one says the demand for hardcover books fell, but the supply curve increased. Okay, so one is saying that the demand curve fell and the supply curve increased. Okay. Does that make sense? No, right? That's probably not going to be right. Because you could, depending on the size of the supply increase, we could actually have an increase in the quantity of books sold. Okay? And the price is going to change as well. Okay, what about letter B? The supply of hardcover books increase, but the demand also increases. No, right? What's going to happen? Output is going to increase, right? If supply and demand are increasing, that's going to increase output. So that's not going to be right. The demand and supply for hardcover books fell. Okay, so we're moving this way and this way. Is that going to be right? That could be, right? Output is definitely falling, but if they decrease in the same magnitude, what's going to happen to price? The price could stay the same, right? If supply decreases and demand decreases by the same magnitude, the price will remain the same. Okay? So the answer to 4 is C. Okay. Question 5. Assume soda and French fries are complements. Suppose that there is a large increase in the potato harvest. At the same time, the price of fructose, which is used in soda, fell due to imports from the Dominican Republic. What would happen to the sale of soda at the fast food outlets like McDonald's? Okay. So we have soda and French fries that are complements. So first we're going to say there's a large increase in the potato harvest. So what is that going to do to these markets? Which market does that impact? Is that going to impact the market for soda? No, right? It's going to impact the market for French fries. And if we have a supply increase, what is that going to do to the price of French fries? Okay, supply is going to be going to the right. So what happens to the equilibrium price? It falls, yeah. P1, P2. Okay, and then we also have the price of fructose, which also falls. Okay, so what's going to happen if that occurs? The price of sugar falls. Which market is impacted here? Soda. Okay, so I'm going to put fries, and then soda. We're going to see exactly right. We're going to see a similar sort of thing. Okay, so now these things are complements, right? So if we see a fall in the price of fries, what is going to happen in the market for soda? Demand is going to increase. Yeah, exactly right. Okay, so we're going to see this demand is going to increase to the right. Okay, so one thing is definitely going to be true in this market. That is that quantity is going to increase, right? No matter the magnitude of these two shifts, we know that the equilibrium quantity is going to increase. What we don't know, though, is what's going to happen to the price, right? If we have a relatively large increase in demand, right? If demand goes up like way up here, what's going to happen to price? It's going to increase, yeah. But what happens if the shift of supply is relatively large? It's going to decrease, right? So we don't know, just with the information given, we don't know what's going to happen to price. Okay, so the answer is going to be D. The equilibrium quantity of soda will rise, but the change in the equilibrium price is ambiguous, right? We can't say with the given information. Any questions? We okay? All right, question 6. Assume the following demand curve and supply equation, and suppose the government taxes consumers $T such that the new demand curve is as given. What is the new equilibrium price and quantity? All right. Now, at equilibrium, we know that the supply, the quantity supplied and the quantity demanded equal one another. So if we have these two equations as they're written, we can get rid of the subscripts, right? The Q subscript D, Q subscript S, and instead just write Q, right? Because we know at equilibrium those two things are going to be the same. All right, now when we do that, we can just set these two equations equal to each other now because we have these two Q's that are the same. So we have 2P equals 100 minus 2 times P plus T. All right, now we can just solve for P. Okay, so we have equals 100 minus 2P minus 2T. We can add 2P onto both sides. 4P equals 100 minus 2T. Now we can divide through by 4. And we get a price equals 25 minus 1/2 T. Okay, so that is going to be our equilibrium price. Right? It depends on the size of the tax. Okay, now to get our equilibrium quantity, we're just going to take our equilibrium price and plug it into either one of these equations that we'd like. Easier one is probably just plugging it into the supply curve here. Okay, so we get Q equals 2 times P. So we get 50 minus T. Okay, so what's our answer? B. Any questions with that one? Yes.
You got the Q.
So remember that you just want to, you can take this and you can plug it into either supply or demand to get Q. So I just took this and I plugged it into Q equals 2P. Yeah, so 25 times 2 is 50. 1/2 times 2 is 1. Question 7. The elasticity of coffee is less elastic than the elasticity of Green Mountain coffee because okay, and the answer is going to be, so we need to go through and think about what are the things that cause things to be more or less elastic. And one of the things that cause things to be more or less elastic is how many substitutes you have for something. Okay, so coffee, more generally speaking, more broadly speaking, doesn't have as many close substitutes. Right? You could have tea, but it's not really the same thing. Whereas a particular brand of coffee, if this changes its price, what are you likely to do? You just buy a different brand, right? If a particular brand gets expensive, you can just buy a different brand, and those are going to be very close substitutes. Okay, so if something has a lot of substitutes, like a particular brand, it is going to be more elastic than something with a more broadly defined market like coffee, which has fewer substitutes. Okay, so the answer will be C. Question 8. Studies show that the elasticity of demand of Baruch College is 0.5 in absolute value. If tuition is currently $8,000 and the state wants to increase enrollment by 10%, by how much should it decrease tuition? So this is a question that we have seen a variation of this already, right? So we even have the same price elasticity. Right, we want, the price elasticity is 0.5, and we want to change enrollment by 10%. So what percent do we need to change price? What was that? 20. Yeah, that part's the same as question 1. Right, we have a 0.5% price elasticity. We want to change quantity by 10%, so we need to change price by 20%. Okay? So 20% times 8,000, right? That's going to be our price reduction. Gives us 1,600. So we need to reduce tuition by 1,600 to increase enrollment by 10%. Okay, so the answer is C. Questions? Question 9. Refer to figure 1, tax 1. Suppose the government imposed a per unit tax of $6. Which of these is going to be true? All right. So remember, when we have a tax, we don't need to think, it doesn't matter who we're going to impose the tax on. We can just take the size of the tax, we call a tax wedge, and just go through and put it until it fits between those two curves. So we have a tax of $6, so we're going to be able to fit that tax wedge right here, right? 1, 2, 3, 4, 5, 6. That's the spot where it fits nicely between those two curves. Okay, so the initial equilibrium price was right here, was 5. Now we have down here, this is 3, and this is 9. All right, so what is the tax burden paid by producers? Well, producers are going to pay $2 of that $6 tax. That's the difference between these two things tell us. Okay, this is the price that sellers are going to receive here. This is the price that buyers are going to pay. Okay, so buyers pay 9, the government takes 6 of it, firms receive 3. Okay, so $2 of that is paid by producers, $4 of that is paid by consumers. So what is the answer going to be then? Yeah, the burden of tax falls primarily on consumers. Very good. And this is something we could have actually done without calculating anything or putting any numbers on here. And we would know that because, well, I guess it's not super easy to see, but this curve is a little steeper, right? And as a curve is steeper, what do we know about the elasticity? It's more inelastic, right? The more inelastic a curve is, the more of the tax burden that they take on, right? So we can see that demand is more elastic, or more inelastic, so we know that they are going to have the higher tax burden. It'll always be that way, right? Because changes in price, they don't change their behavior very much. So as taxes increase, they're going to bear the most of that burden. All right, question 10 asks, how much does this change total surplus? So to answer that question, we just need to let's put this on here real quick again. All right, so the initial quantity was up here at 60. That was the initial equilibrium. After we impose this tax, we put in this $6 tax wedge here. Our quantity is going to fall down to 20. Now, our initial total surplus in this market, remember the total surplus is going to be the difference between how much you're willing to pay, which is your demand curve, above the amount that sellers are willing to sell, right? So this whole triangle initially was your total surplus. But now you're losing a lot of that surplus, right? You no longer sell 60 things. You only sell 20 things, right? So all the surplus you got from those additional 40 things has completely gone away, right? That's a loss in surplus because we imposed this tax. Okay, so this area here is going to be the change in our surplus by imposing this tax. And we have a name for that. What do we call it? Yeah, our deadweight loss. Okay, so what is, to calculate the area of a triangle, it's going to be its base times its height divided by 2, or multiplied by half. So what is the distance along the horizontal there of that triangle? Say it again. Yeah, exactly right. Yeah, so the horizontal distance here is 40. The vertical distance here of that triangle is 6. Equals 120. So the change in surplus, or the deadweight loss from imposing this tax, is going to be $120. That's a 6 right there. Okay. Assume the carpenter and plumber can switch between fixing doors and fixing sinks at a constant rate. This left side of the table here is the hours they need in order to fix one of these two things. And the right panel here is the number of doors or sinks they can fix in an 8-hour period. Now, I think probably the things you're most likely to have seen on MindTap is over here. We're gonna just stick with this right panel. It can get confusing when you're looking at both of them, I think. So if you see one that's like this, just translate it into how much you're able to do in a working day. It'll make it easier on you. Okay, so we're assuming that the carpenter and the plumber each have 8 hours of labor available to them. If each person divides his hours equally between fixing door and sinks, what is the total amount of production? Okay, so we're basically saying that these cells tell us how much they could produce if they spent all of their time doing that one thing. Okay, so if he spent all 8 hours, he could produce 8 or fix 8 sinks, and the carpenter, if he spent all of his time producing with sinks, he could produce 2 sinks. Okay, so if the plumber spends half of his time, how many sinks would he make or would he fix? 4. And how many would the carpenter fix? 1. If he spent half of his time plumbing, and what about the carpenter? 2. 4, 5. Okay, so if they each split their time, there would be 4 doors and 5 sinks. So the answer to this one will be C. Okay, question 12 asks us about the absolute and comparative advantage. So first, we can just kind of look at this and say what we know about absolute advantage, which is pretty straightforward. So who has an absolute advantage in sinks? The plumber, right? He can produce more. He can produce 8. The carpenter can only produce 2. Who has an absolute advantage in doors? Neither, right? Neither has an absolute. They're both able to produce 4. Neither of them is, if they spend all their time on doors, is able to produce more than the other. Okay, so now we need to look at comparative advantage. So let's look first at the carpenter. All right, so let's calculate his opportunity cost. So opportunity cost, and I'm going to say OC subscript D for the opportunity cost of doors. Okay, so to produce 4 doors, how many sinks does he need to not fix? 2. Okay, so to produce 4 doors, he has to give up producing 2 sinks. So if he were to only produce 1 door, how many sinks would he have to give up? A half. Okay, so that's his opportunity cost. The opportunity cost of producing a door for the carpenter is 0.5 sinks. Okay, alternatively, if he were to produce two sinks, he would need to give up 4 doors in order to produce that. So how much would he have to give up to produce 1 sink? 2 doors. Okay, so those are the carpenter's opportunity cost for both doors and sinks. Okay, so let's do the same thing for the plumber. If the plumber were to produce 4 doors, how many sinks would he have to give up? 8. Right? If he spends all his time on doors, he can fix 4 of them, but that would mean that he would not be fixing, he wouldn't have any time to produce any sinks. He'd have to give up producing 8 sinks. Okay, so then to produce 1 door, what is his opportunity cost? 2. Okay, so finally, he has to, in order to produce 8 sinks, he needs to give up producing 4 doors. So then if he were to produce 1 sink, what is his opportunity cost? Very good. 0.5 doors. Okay, so who has a comparative advantage in doors? Yeah, I mean, it's kind of obvious with the names, right? But we can also look at the opportunity cost. It's 0.5, right? He only has to give up 0.5 sinks, whereas the plumber has to give up 2 sinks, right? So it is cheaper for the carpenter to produce doors. So he has a lower, so he has a comparative advantage, right? He has the lower opportunity cost, so he has a comparative advantage. Who has a comparative advantage in sinks? The plumber does. Yeah, his opportunity cost is 0.5 doors, whereas the carpenter's opportunity cost is 2 doors. Okay, so let's see which of these is right then. The plumber has an absolute advantage in sinks and a comparative advantage in sinks. Right, D. Does that make sense? Question 13. We have these supply and demand equations, and we want to know what is the producer's surplus. Okay. So we're going to have our supply and demand equations. We're going to have an equilibrium point. And then our producer surplus is going to equal the area underneath what that equilibrium price is and above your supply curve, right? This is the price that people are willing to sell their products at. This is the price they actually receive for their products, right? So the difference between those things is the surplus they get above the minimum price they're willing to sell their products for, right? That's what we're aiming for with this question. Okay, so we just need to get the different points surrounding this triangle so that we can calculate the equilibrium. Okay, so the first thing we need to do is calculate our equilibrium. And to do that, we just set our supply and demand equal to one another. Okay, so we have 100 minus 10Q equals 10 plus 5Q. Right, we just set those two things equal to each other. We subtract 10 on both sides. We get 90, add 10 to both sides, we get 15. So our equilibrium quantity is going to be 6. Everyone see how we got that? All right, we're just setting supply and demand equal to one another and solving for Q, which gives us our equilibrium quantity. Okay, so we've been able to fill in one thing there. What are we going to do next? Yeah, we're going to plug that in. So we just take this and we plug it in to either one of those equations. Right? So I'm just going to plug it in to this one here. P equals 10 plus 5 times our equilibrium quantity times 6, and our price equals 40. Good. Okay, what is the intercept here? Where does the supply curve hit? At 10. Good. All right, so how do we get the area of that triangle?
30 times 6 divided by 2.
Yep, very good. So our producer surplus is going to be the base of this, is going to be 6 times the height of it, times 30. And then it's a triangle, so multiplied by a half. Which will be 90. Yeah.
How I got 10 again?
Yes. Okay, so we want to know where the supply curve hits the y-axis here, right? So we just go up here and we say, what is the price if quantity equals 0? If quantity equals 0, price is 10. Any other questions? Okay. So we're just going to extend the same question. We're asked what would be the result of a $30 price ceiling. Okay, so we're coming in here and saying this is a price ceiling. It is a maximum price that you were able to sell this product. Now, first of all, we should ask ourselves with these questions, is this a binding price ceiling? It is. Yeah, anytime your price ceiling is less than your equilibrium price, it is going to be binding. Had this question said 50, then it would not be binding, right? Because our ceiling is higher than our equilibrium price, and it would mean that nothing would change. But here, because it is less, it is going to be a binding price ceiling. All right. Now, first of all, it's a binding price ceiling. So let's right off the bat, are we going to have a shortage or a surplus? We're going to have a shortage. Yeah, very good. Because our quantity demanded is going to be greater than our quantity supplied. Right? We just go across at 30, and where we hit each of those curves tells us what our quantity demanded and our quantity supplied is. We can see that our quantity demanded is in excess of our quantity supplied, so we have a shortage. All right, so I'm just going to go ahead and cross off A and C. All right, now to get the size of the shortage, we're just going to take that price and plug it into both our demand and our supply equations and see what our quantity demanded and quantity supplies are at that price. Okay, so let's start with supply. Okay, so we plug in the price, and we get 30 equals 10 plus 5Q. Subtract 10 from both sides, we get 20 equals 5Q. Divide both sides by 5, and we get, sorry, I'm going to put in QS here, right, because it's not an equilibrium, so we can't say quantity supplied equals quantity demanded. Our quantity supplied is going to equal 4. Okay, so I'll put this in here. All right, now let's do the same thing for demand. Price of 30 equals 100 minus 10 QD. So we get 10 QD equals 70, and QD equals 7. We're going to have a shortage of 3,000 units. Because the difference between those two, 7 and 4 is 3. Good? Any questions? Question 15. Assume this is a market for baseballs. If the world price is $8, this country X allows free trade, then which of these things will be true? Okay, so to start, I'm just gonna, it's kind of hard to see. This is 4, 6, 12, I think. No, it's an 8. There we go. Okay, so to start, I'm just gonna put in the world price. Put that in there. P world equals 8. Okay, so if the world price is less than our equilibrium price, what sort of country are we? Are we an exporter or an importer? Import. We can buy things cheaper abroad, so we're going to buy things from somewhere else and bring it in. Okay, so let's see which of these are true. We know that it is not going to be an exporter. So let's look at A. They will import 6 goods. Well, let's see. So domestically, we are going to produce, can't see what these say. Okay, sorry, this crosses here at 7 and 18. Okay, so domestic suppliers are going to supply the first 7, and then we're going to import the remaining 11 at that world price. So we're not going to import 6, we're going to import 11. Domestic suppliers are not going to produce 11, they produce those initial first 7, right? And that's all they're willing to produce at that price, and then we get the rest from an international market. Okay, so the answer will be C. They consume 18 things. Does that make sense? Okay. So remember, our supply curve represents how much firms are willing to sell at every given price. So here we have this world price of 8. Right? This is the price that prevails internationally. So we are going to buy this good at that price. Right? We're not going to buy it anymore at the closed market equilibrium price when we can buy it from another country for $8. Okay, so local firms they have to sell it at $8 too. Okay, so at $8, firms are only willing to sell 7 things. Right, that's what we get from the supply curve. World price is $8. We're only willing to supply 7 things. Now, at $7, consumers would like to buy 18 things. But again, local firms are not willing to do that. So to get the remaining 11 things, we need to go out to international countries and buy those 11 things from them. Okay, so that's why the difference between these two here is going to be our imports. Right? Because what would happen if, let's say this is a closed market, and we said price is $8. What would we have? What would that cause? What did we have in when we had the price ceiling in the previous example? What did that create? Yeah, shortage, right? Because firms are only willing to produce their quantity supplied, whatever that happens to be, where that price is. Okay, so then if we want to buy those remaining goods, we need to go to an international market. Okay? Question 16 asks, consumer surplus in country X with free trade is going to be what? All right, now remember, our consumer surplus is the surplus value we get above what we have to pay. Okay, so the demand curve represents what we are willing to pay for a product. This world price, this is what we actually have to pay. So our surplus is going to be the difference between our demand curve and the price we actually have to pay. So it is going to be that whole triangle right there. Okay, so the base of that triangle is 18. The height of that triangle is, I can't see that. It's at 17 up there. The base of that triangle is going to be 9. And it is a triangle, so we multiply by 1/2. Very good. We 81. Our consumer surplus is 81. Make sense? Now, it's not asked here, but if we wanted to calculate producer surplus, what would we do? Remember, it's the excess value they get from selling their stuff. So is the area going to be above the supply curve? The supply curve is the minimum price they're willing to sell and the actual price that they receive. So the producer surplus is going to be that little triangle there. Okay. Again, it's not asked, but if you were to do that, it would be 7 times 4 divided by 2. Okay, so it'd be 14. All right. So we're still saying we have a world price of 8, but in this example, we're going to say that we impose a tariff or a tax on imports equal to $1. And then we're going to see which of these things is true given that. All right, so let's graph it first. Okay, so our price world plus T, it was $8, but now we have a $1 tariff above that. So we're just going to shift our world price from 8 up to 9. Okay, so our new quantity supplied is going to be 9. And then if we go all the way over to our demand curve, our new quantity demanded is 16. All right, so let's look at each of these things. Consumer surplus fell by 17. Let's see if that's true. So you guys tell me, what is our consumer surplus here? What is the base of that? 16, yeah. 1/2 times 16 times 8. Yeah, the height of this from 9 to 17 is 8. Okay, so our consumer surplus is 64. So what was our change in consumer surplus? It was 17. Okay, so we know A is true. But one of the options is all of the above, so let's see if the other ones also happen to be true. B is government revenue is 7. Is that right? Yes, it is. Right, the size, that's going to be represented right there. Right, the size of the tax multiplied by the number of items that are taxed. So here there are going to be 7 imports, right, between 9 and 16. And the price, the tax on each of those imports is 1. Okay, so the government revenue is going to be 7. And C is producer surplus rises. Is that true? Yeah. Right, it was this little triangle here. Now it's going to be this slightly bigger triangle right there. Okay. Any questions on that? Good. So the answer is going to be yes.
Is it because it's a tax on the world price that the tax tariff is only that section from 9 to 16? Like, how about the section from 9 to 0? Isn't that normally a like tax revenue too?
So tax revenue from 9 to 0. This is producer surplus, right? That's the point of doing this, a tax like this, is to help domestic producers, right? So they used to have to compete with this $8 price, but now they only have to deal with a slightly higher price. So they're able to sell more stuff. Remember, this over here to the left of when domestic producers stop producing, that is our imports. So the tax revenue is only going to be on those things. What you're thinking of, I think, is just a normal tax on a good. So if you were doing, if you had just a normal market without trade and you had a tax, you would put in that tax wedge, and then that area right there would be your tax revenue. Yeah. So this one you're taxing everything. This one you're just taxing the imported goods. Yeah.
Thank you.
Yeah. Okay, so the answer is D, all of the above. Question 18. What would happen if the world price rose from $8 to $13 and there was no tariff? All right, so I'm going to erase all this. All right, so this equilibrium price here without trade is 11. So if we increase it to 13, what sort of country are we going to be? If we increase the world price to 13, what sort of country are we going to be? We're going to be an exporter, yeah, because we can sell our product for more money abroad than we can domestically. Okay, so we go up here to 13. Then we can go across at 13 and find the quantity supplied and the quantity demanded, which, let's see, at 13, thank you, 8 and, what was it? 15. 8 and 15. Okay, so then which of these is going to be true? So would consumers in country X buy 15 goods? Domestic consumers, how much are we willing to buy domestically in country X? Let's see, this is our demand curve, right? So where does price hit the demand curve? At 8. That is all the domestic consumers are willing to buy. Okay, so this is wrong. What about B? Are we going to export 12 goods? Yeah, how many do we export? 7, right? We export 7. 8 buy domestically, 15 are the total amount that we were willing to supply at that price. So the difference between those is going to be our exports. Okay, so we know this is wrong. So now we're left with the total surplus rise or the total surplus fall. So to answer this question, we're going to need to calculate the total surplus now relative to the total surplus when the price was $8. Okay, so let's just briefly go back to so we know that our total surplus is going to equal our producer surplus plus our consumer surplus. And we know from before that our consumer surplus was what? 81. And our producer surplus was, it was 14, I think, right? Okay, so our total surplus when we were an importer is $81. So now that the price increased to 13 and we are an exporter, let's compare what our surplus is. All right, so first let's calculate our producer surplus. How are we going to get that? Remember, it is the area underneath the price and above your supply curve. It is the excess value you get above the minimum price you are willing to sell your product. Right? So this you are receiving this first good here, right? You were willing to sell it for $4, but the price is 13. So the difference between those is the surplus value you get above the minimum price you were willing to sell. So the total surplus then is going to be that whole triangle, right? That is your producer surplus. All right, so what is the base of that triangle? 15. What is the height of that triangle? 10, and then it's a triangle, so we multiply by a half, and we get 75. Our producer surplus is 75. Okay, what about our consumer surplus? What was that top number there? 17. Okay, consumer surplus, the area below the demand curve and above the price. So what is that going to be for us here? What is the base? 8. What is the height? 4. Yeah. Right? The base, they buy 8 things domestically, and the height of that triangle is 4. So 1/2 8 times 4 gives us 16. So our total surplus then is just going to be adding those two things together, a producer and consumer surplus. So 75 plus 16 gives us a total surplus of 91. So what happened to our total surplus when the world price went from $8 to $13? It fell. Yeah, good. So the answer to 18 is A. All right. So here we're deciding whether to buy a Costco membership, which costs $100. The benefit being that you get products for a lower price. We assume the demand curve for that bundle is going to be P equals 100 minus 20Q. And without a Costco membership, you would buy 3. And with a Costco membership, you would buy 4. OK, so let's start here by graphing our demand curve. Okay, so our intercept up here is going to be 100. Right? If quantity equals 0, then price equals 100. So that will be our intercept. And then our slope, right, we're going to go down 20 and over 1. So if we go down to 80 and then over to 1, down to 60, over to 2, 40, over to 3, and 20, over to 4. All right, there is my squiggly demand curve. All right, so we've drawn our demand curve. The next step is so we're worried about our surplus here. So the next thing I'm going to do is just calculate our consumer surplus if we consume 3 things. So if we consume 3 things, that means that the price is going to be $40, right? Because to get 3, we need a price of 40 will induce us to buy 3 things, right? So then our consumer surplus is just going to be the area underneath that demand curve. All right, so the base of this then is going to be 3, and the height is going to be from 40 to 100. Yeah, so 1/2 times 60 times 3 equals 90. Bless you. Okay, now if you had a Costco membership, the prices are lower. So we're saying that it is low enough that you would buy 4 things. So then the price that would induce us to buy 4 things is a price of $20. Right, and you get that by plugging in 4 here. You plug in 4, you get a price of 20. Right, so that's the price that would induce us to buy 4 things. Okay, so now if we do that, our consumer surplus is that whole triangle all the way down to 20 and over to 4. So now the height of that triangle is going to be what? Very good, 80. And the base of that triangle equals 160. Okay, so what is the increase in your consumer surplus by getting your Costco membership? $70. But what do you have to pay in order to get that Costco membership? $100. So what is is that worthwhile then, to get $70 worth of surplus? Or pay $100 to get $70 worth of surplus? No, yeah, exactly, it's not worth it. Okay, so B, don't buy the membership because your consumer surplus will be $30 less. Okay, now would that change if the fee was only $50? Yeah, right? You would get $70 in additional surplus at a price of $50, so it is worth it. Goes from 90 to 110. Answer is D. Question 21. We have this willingness to pay schedule for Duff. And we want to know which of the following is true. All right. So here we have an external cost of $3. We have an external cost of $3. All right, so the first thing I'm going to do is pretend we don't have an external cost. Okay, so I'm just going to find our equilibrium if we did not have this externality. All right, so we know the price is 3.5. Okay, so if you have a price of 3.5, how many of these beers are we going to buy? 3. Yeah, we're going, or 3. We're going to buy it so long as the benefit we get from buying it is bigger than the price. Okay, so for this first one, we get $9 worth of benefit, and it costs us $3.50. So then, what is our consumer surplus for that one item? Not close, not 6, but yeah, 5.5. Right, 9 minus 3.5. Okay, what about for our second one? 3.5. The third one? 1.5. Very good. Okay, so this is how we are going to, this is how we make our decision, right? This is how we make our consumption decision, right? Externalities by definition are not captured by the market. So we make our decisions based on our private valuation, right? So if we don't take any measures to intervene in this market, we are going to consume these 3 beers. Okay, but we know that if we do that, it bears a $3 external cost. So the actual consumer surplus, right, the true consumer surplus is going to be this minus the external cost. So 5.5 minus the external cost of $3 gives us a consumer surplus of 2.5. Right, so this is the private valuation. This is society's valuation here. All right, what is society's consumer surplus for the second can? If the private is 3.5 and then there's a $3 external cost, 0.5. Yeah, 0.5. What about for this one here? Minus 2, right? The private valuation is 1.5, but there's a $3 external cost. Sorry. Negative 1.5. Right, 1.5 minus 3. Okay, so we know that if we were, yes? Because there is Each can has an external cost of $3. Right? So when we're making our decision about how many beers we're going to drink, we do that just based on our private valuation. Right? Because external costs, by definition, are not considered in the market. Right? But they have an impact on society. So the society's consumer surplus, you need to include that -3. I saw a few other hands. No? Okay. Okay, so we know that by ignoring this $3 external cost, we are reducing society's consumer surplus by $1.50 per person, right? How many beers would you drink if we included the external cost? 2. Yeah, if, for instance, we added a $3 tax per beer, then we would only consume these first 2 beers. And we would save society a deadweight loss of $1.50 per person. Okay? So, B, right? A corrective tax of $3 per can would increase total surplus by $1.50 per person. Does that make sense? Okay. All right, so in this question, we have 3 people who are polluting. From A, B, and C, this is the amount that they pollute, and this would be the cost of them reducing each of those units of pollution. So the government would like to reduce the total amount of pollution to 120 units, and their first idea in order to achieve that is to just say each of you need get 40 pollution permits, and then anything above that 40 you need to reduce. Okay, so firm A, they don't need to do anything, right? If they can't trade their permits, they don't need to do anything, right? They produce 40 units of pollution, and they get 40 credits to pollute. So they're fine. How much does firm B need to reduce their pollution by? By 20. Yeah, they have 40 permits. Anything above that, they need to eliminate. So they need to reduce by 20. All right, what is the cost of reducing those 20 units of pollution? For firm B. Per unit. 14. Okay, so the total cost of reducing pollution for firm B is $280. What about firm C? How much do they need to reduce their pollution? 40. Yeah. Right? Because they're allowed, they have 40 permits, so they can't trade to anyone, and they need to reduce their pollution. Anything above that 40, they need to eliminate. So they need to eliminate 40 units, and at cost of what? 28. And that equals a number. Someone help me out. What does that equal? What is it? 2 zeros. 2 0. Facing 2 zeros. Okay. So that is the total cost of reducing the pollution if we are not allowed to trade our permits. Okay, if we are allowed to trade our permits, then firm C doesn't want to reduce their pollution, right? They want to buy as many of those permits as they can, and what's going to end up happening is the firms that have the lowest cost of reducing pollution are going to end up being the ones that end up reducing their pollution, right? They'll sell their permits to the ones that are more costly, and they'll end up the ones that that reduce their pollution. So we need to reduce our pollution by 60, right? Who are going to be the firms that end up doing that? Firm A and B, right? Because it's much cheaper for them to reduce pollution. So they're going to sell their permits to firm C for something more than the price that they paid, right? And then they're going to reduce pollution. Okay, so it's going to be 40 times 7, right? They're going to reduce all 40. The firm A is going to reduce all of their pollution, eliminate all of their pollution. And then we're going to add the 20 remaining from firm B. Okay, and then the difference between those two things is going to be the reduction in your pollution when you allow for tradable permits. And that's going to end up being B. Right, the reduction in the cost of these permits is going to be $840 when you allow them to be traded. These pollution permits, sorry, there'll be $840 decrease in the cost of pollution when you allow the permits to be traded. All right, so just remember when you answer those questions, whoever can do it cheapest is going to be the one that eliminates their pollution. It's always going to be that way. Because if it's expensive for you to reduce your pollution, you would rather go buy permits that allow you to continue to pollute. And if it's cheap for you to eliminate pollution, you're willing to sell your permits to other people. All right. Question 23. What would be the result of a $15 minimum wage? So to start answering this question, let's just see what our equilibrium wage was before we imposed our minimum. So our equilibrium, remember, is always going to be with the intersection of our supply and demand. At the intersection of our supply and demand, quantity supplied, quantity demanded equal one another. So at what wage are quantity demanded and quantity supplied equal? Yeah, good. So our equilibrium wage is 12, because that's when quantity demanded and quantity supplied are the same, right? They're both 8 here. Okay, but we are going to put in a $15 minimum wage. So I'm going to W subscript M there for minimum. And at that wage, we have a quantity demanded of 5 and a quantity supplied of 11. Okay, so let's see which of these is true. A says we have 11 million full-time unskilled workers supplied in this market. Is that true? How many workers are supplied when we have a minimum wage of 15? 11. Yeah, so is A true? Yeah. B, 5 million full-time unskilled workers demanded in this market. Is that true? Yes, it is. Unemployment rate of 6 million full-time unskilled workers. Yes, right? The difference between 5 and 11, 11 people want to work. They're only hiring 5. So the unemployment is going to be 6. All right, so D, all of the above. Question 24. Georgia Agricultural Commissioner Gary Black says that he expected Hurricane Michael to impact Georgia farmers the impact would be severe, including possibly damaging 80% of the state's cotton crop. So which of the following would we observe? A reduction in the supply and the demand for cotton. Is that true? No, why not? Yeah, yeah, this isn't going to make us demand less cotton, right? That doesn't make any sense. B, a reduction in the supply of cotton and a decrease in the quantity demanded. Is that true? Yeah. Yeah, exactly right. Right, supply curve shifts back. That's going to decrease the quantity demanded, which this was clearly going to do. Question 25. Suppose we observe a decrease in the equilibrium price of iPhones and an increase in the equilibrium quantity of iPhone cases. What could be responsible for this pattern? So first of all, what are iPhones and iPhone cases? Yeah, they're complements. Very good. Okay, so a decrease in the price of Samsung smartphones. No, that's not. What is that going to do? A decrease in the price of Samsung phones. What would that do in this market? It's going to increase demand, right? Because they're substitute goods. So if the price of Samsungs goes up, that's going to increase the demand for iPhones. What will that do to the price? It's going to go up. So we know that's wrong, right? Because it says there's a decrease in equilibrium price. So we know that A is wrong. All right, B, a decrease in the price of plastic used in iPhones. What is that going to do? It's going to increase supply. So if we increase supply, it's going to be you can think of that as a rightward shift or a downward shift in supply. What is that going to do to price? It's going to decrease price. If price decreases, what's going to happen to in the market for iPhone cases? It's going to increase what? Well, so if price of a complement goes down, what happens to the other thing? It's going to increase demand, right? Increase demand. If we increase demand for iPhone cases, what's going to happen to the equilibrium quantity? It's going to increase. Yeah, good. Okay. So B is going to be our answer there for the last question. All right. Any questions? Yeah. 2 through 9. Yeah.
We did questions 21, the external factors of chapter 10. So I was wondering why it was included.
That is a good question. Ask your professor. If you got to chapter 10, then it'll be on the exam. If you're in my class, it goes to chapter 9. I think most of us are just to chapter 9. Yeah, so ask your professor to be sure. Other questions? Yeah. Yes. What number?
That there was consumer tax that was on imports and the domestic product. What would be considered the revenue that the government collects in that case? You know, for the tariff is that little rectangle in the middle.
Yeah.
So if it was on both imports and the domestic products, both of them, what would be the
Oh, you won't see that. No. Yeah, that's too much going. Yeah. No, you won't see that. Other questions? Yeah.
It
was not A because. Let me look at the. Oh, decrease in the price. So Samsungs are a substitute. So a decrease in the price is going to increase demand for iPhones. So the price would go up. Yeah, and then we were saying we observe a decrease in price. Other questions? Yeah. 25. Yep. Anything else? Yeah.
Can you go over the answers for 19 and 20?
Hey guys, can you keep it down just for a minute? Okay, so he has to go over 19 and 20 again. So the idea here is you're going to have the option of getting a Costco membership to get something at a lower price. Without the Costco membership, the price is such that you buy 3 things. So if the price is 3, you are going to, if the quantity is 3, the price is going to be $40, right? And we got that because we plugged 3 into the demand equation, and we get 100 minus 20 times 3 gives us 40, right? So that's the price that will induce a quantity of 3, right? And then you have, to get your consumer surplus at that level, you just calculate the area of this triangle. So we know this hits up here at 100, which means our consumer surplus is 160, or 90, sorry. Our consumer surplus is 90, right? The base of this is 3, the height of it is 60, so the area of that triangle is 90. Now if we had a Costco membership, then we would buy 4 things. So we know the quantity is 4. If we plug 4 up into the demand equation, then we get a price of 20. So the price that induces us to buy 4 things is 20. So our new consumer surplus, if we have a price of 20, is going to be the area of this triangle right here. Right, so that's 160, I believe. Right, 80 times 4 divided by 2. Right, but then we also have that $100 we need to pay for our membership. So the net consumer surplus we get out of this is only $60. And without a Costco membership, our consumer surplus was 90. Right, so we would lose $30 in surplus by getting that Costco membership. Right? Okay. So the question to 20 is just the only difference is that the cost of that membership is now 50. So instead of subtracting 100 here, you're subtracting 50, which gives us a consumer surplus of 110. So if the price is only $50 to get that Costco membership, it's worth it because our net consumer surplus is 110. Whereas without the Costco membership, it's only 90. So our consumer surplus increases by $20, right, by getting the membership. Okay? Yeah. Yeah. Okay, question 1 says that we have an elasticity of 0.5, and we want to decrease beer consumption by 10%. So this 0.5 means that a 1% change in price will decrease your quantity consumed by 0.5%. So 1% increase in price decreases your quantity by 0.5%. But we don't want to decrease our quantity by 0.5%. We want to decrease it by 10%. So if increasing it by 1%, price by 1% decreases quantity by 0.5%, how do we decrease quantity by 10%? We have to increase price to 20. Does that make sense? You can say no. It's okay. Make sense? Okay. Yeah.
You do number 8 and 10.
1 second. Chia has for 2 also. So the easiest way to do this one is just to note that you want approximately a 20% increase in price, right? We know that from question 1. Which of these is closest to a 20% increase? A is closest. The way that you would actually go through and solve this explicitly is by calculating, so you know the percent change in quantity is 10%, and then you're using the midpoint method. So we know that the midpoint method is going to be the change in price divided by your average price. So it's going to be 0.10 divided by, we don't know where we're calculating our new price, so we just put in a p minus 10 divided by the average of those things, so P plus 10 divided by 2. And then we know from question 1 that equals 0.5. Right? So we're just plugging in the midpoint method here. Right? So I'm not going to go through the algebra. We did that earlier. But if you just solve for P, then that will give you 12.22. Okay. You said... Okay. So this is a similar question here, but we were asked... we're given the same framework where we have an elasticity of 0.5 and we want to decrease enrollment or increase enrollment by 10%. Right? So we want to change price by 20%. Right? For the same reason of number 1. All right, so 20% decrease of 80 or of 8,000 is 1,600. Okay, this question asks, how does the surplus change? So we know that we have a tax of $6, so we just put in the wedge here. Right, the place where we can find, so we see it's 1, 2, 3, 4, 5, 6. So that's where the wedge fits. And then the area to the left of that is going to be our deadweight loss. So if you just find the area of that triangle there, that is the change in surplus by using this tax. Right, because if this is a tax, this is all we consume. We consume 20. So the surplus we got from that additional 40 items, we don't get anymore. Okay? So that area of that is going to be your deadweight loss. I believe it's 120. Any other questions? Yeah. Number 2? Didn't we do number 2? We just did 2. We just went over it. Remember, it's the midpoint method. So you do 0.1 divided by change in P divided by your average P. And then we don't know what one of those, we're solving it for one of those P's. So you do 0.10 divided by P minus 10 divided by, and then if we were to average P and 10, it'd be P plus 10 divided by 2. And then we know from question 1 that equals 0.5. We know our elasticity is 0.5. So then we just solve for P. Okay? Anything else? Okay, yeah, so we have 2 complement goods, and we have an increase in the potato harvest and an increase in the price of fructose. All right, so we want to know what is going to happen to these goods. So first of all, we have this increase in the potato harvest. So what is that going to do to the price of potato chips or fries? It's going to decrease, right? Increase in supply, it's going to decrease the price of potato chips. Hey, guys. It's going to decrease the price of potato chips. What is that going to do to the market for soda? They're complements. So we have a decrease in the price of potato chips. Yeah, it's going to increase the demand for potato chips. An increase like that. Now we also have the price of fructose falling, right? Yes, falling. So what is that going to do to the market for soda? We have a decrease in the price of sugar. what is it going to do to the market for soda? Increase. You guys know this. Supply. Yeah, an increase in supply. Right? Our inputs are lower, so our supply is going to increase. Okay, so one thing we know for sure is that quantity will go up, right? Increasing supply, increasing demand means that our quantity of soda is going to go up. Now, we don't know what's going to happen to price, though. As I drew it, it looks like price didn't change. But what happens if the supply increased by a whole lot? What would happen to price? So instead of drawing it like I did, let's say supply was increased out to here. So here's our new equilibrium right there. And we started up here. So there, as I drew it now, price went down because we had a relatively larger increase in supply. If we had a relatively larger increase in demand, price would go up. Okay, so we don't know what happens to price, but we know that quantity of soda at least is going to go up. So the answer to that is D. Yeah.
Can you go over number 11?
Okay, so here you're calculating opportunity cost. Or no, number 11, you don't have to do that. So we're saying they each split their time equally. So these both represent the amount that they would produce if they spent all of their time doing that particular thing. So if they spend half their time, the plumber, if he spends half his time on sinks, he can produce 4 of them. If the carpenter spends half his time on sinks, he can produce 1. So the total amount of sinks, if they split their time, will be 5 in this market. If they each split their time here, if they spend all their time, they can produce 4. If they split their time, they can produce 2. So it'll be 4 doors, 5 sinks if they both split their time equally.
Could you go over question number 22 again, please? And 21.
I'm gonna skip 21 because I think you guys are right. I think this was, you really tested up to chapter 9. Yeah, so you shouldn't be asked 21. But 22, the idea with 22 is that you have a scenario where you can either where you cannot trade the permits or you can trade the permits. So if you can't trade the permits, then everyone just will pollute 40 units of pollution, and then anything in excess of that they need to reduce. Okay, so it's going to be 20 times 14 plus 40 times 28. Right? That's the total cost of reducing pollution when they cannot trade their permits. Okay, but if they can trade the permits, the people that can do it most cheaply are going to be the ones that end up doing it. Right? So when you have permits, this guy's going to reduce all of his pollution, right? And this guy's going to reduce the remainder. Okay, so 7 times 40 plus 14 times 20. Right, so the difference in those things is just going to be the reduction in the total cost.
So the answer is 140, but when you add them up, it's
560.
Yeah, 560.
1120 minus 560.
Okay, let me think about that for a second. That should be the amount. Let me come back to it. 1 second. Do you have any other questions? Okay, let's wrap it up. Thanks, guys.